Today our topic is diffraction of light. First of all, we understand the definition of diffraction. So when waves, for example, here is a light waves, right? So when waves encounter with some obstacle, here is the obstacle, here slit acts as an obstacle. Then these waves will bend around the edges of this obstacle or slit. But here is a condition. If the dimension of obstacle, that is width of slit, are comparable to the wavelength of waves, that is lambda, then bending of waves around the edges will occur. It is called diffraction. In a simple way, if the dimension of slit is comparable to the wavelength of waves, then bending of waves occurs around the slit. It is called diffraction. Right? Now we will understand these three images. So here width of slit is d and wavelength of wave, it is lambda. So what happens when d is greater than lambda? So there is no diffraction. So what happens? This wave will pass like this, right? But when the width of slit is approximately equal to lambda, then diffraction will occur. Now we will understand these three images. So when the opening is large as compared to the wavelength, then waves do not bend around the edges. So here the width of slit is d and wavelength of wave is lambda. So when d is greater than lambda, then there is no diffraction occur, right? But when the opening is small, it means that it is comparable to the wavelength of waves, then diffraction will occur, but it is noticeable, right? When the opening is very small, that is d is less than lambda, then what happens? The wave will spread over the entire surface behind this opening. So here opening acts an independent source of wave which propagates in all this direction. Here is a one GIF image. In this GIF image, we can see the diffraction of light. Here is a plane light wave which encounter with some obstacle, then diffraction of light will occur. Now we will understand these images. So here we can see the 3D view of diffraction of light. Here is a plane wave front of light which is encountered with this slit, then diffraction of light will occur. Here we can see that the diffraction of light will occur at the edges of this razor blade. We have also a common experience that path of light which is entering in a dark room through a small hole in the window which is illuminated by sunlight, then path of light is always straight, right? If some disturbance appear in the path of light, then what happens? We can easily see a sharp shadow on screen, right? Also the rectilinear propagation of light can easily explain on the basis of Newton's corpuscular theory. But it is observed that when a beam of light entering through a small opening or a circular hole or a narrow slit, then what happens? This light wave will spread to some extent into the region of geometrical shadow. So here is a geometrical shadow, right? So if light energy propagate in the form of waves. So it is similar to sound waves. That's why we expect bending of beam of light around these edges. Right? So diffraction phenomenon is not easily appear in the case of light waves. It becomes significant when the aperture size, that is the width of slit, is order of wavelength of light waves. If you have a question regarding diffraction of light, then please comment below.